Hi everyone, this is Mr. Gale, and I want to take this time to demonstrate the digital chipboard that I'm going to link to the next assignment. And I just want to make sure you know what to do when you hit that link and you see this screen here. You'll see this box and it's got some tools for you to use. Now, first of all, a little bit of background. Once upon a time, back in the Depression and beyond, when people made money, they used a reference to say that they were doing really well, making a lot of profit. And that was to say that they were in the black. Now, if they weren't doing very well, they used in the red to say that they were either in debt or that they owed money. So we use black chips to represent positive values. And if you want to add a black chip to this screen, you click the plus sign down here in the corner and then click the screen and you have a black chip. And as long as that's highlighted, you can click as many as you want. So I clicked 4 times and I got 4 black chips. So let's now add some negative chips, some red chips. 1, 2, 3. All right. So now I can set up an equation. There's a text box up here that if you click on it, it adds a little text box. I'm going to type the problem here. So we've got positive 4 plus negative 3. Notice I put the negative 3 in parentheses to show that this negative sign right here is different than this plus sign, which is a sign of operation. This is a sign of identification. This is a sign of operation. So 4 plus negative 3. Use the parentheses to differentiate that. And equals, and we're going to find out. 4 plus negative 3. So one thing that we can do here is if we put these things together, bam, that's a 0, bam, that's a 0, bam, that's a 0. And it's a 0 because negative 1 and positive 1 added together makes 0, right? If you take 1 and you subtract it, that's 0. You take 1 and you subtract it, that's 0. So now we have 0 plus 0 plus 0 plus 1. So 1 is our answer. So if we click back up here, we can show that our answer is 1. Okay? That's how to show addition using a chip model and using this particular digital chip model. Now there's a way to show subtraction as well. In particular, let's try modeling a different problem, subtracting a negative number. All right, I'm going to hit the reset button. If you hit the reset button, it cancels all your work. It says this will clear all your work. Are you sure? Of course I am, or else I wouldn't have clicked it. There it is. So now I've got a blank screen. I'm going to, let's say, start with 6. 1, 2, 3, 4, 5, 6. Positive 6, and I want to subtract negative 3. Now, I'm not just going to put some negatives up here, because if I just put negatives, let's do that. 1, 2, 3. Now I've added negative 3. And we know that if we were to match these up, the 3 of these would be canceled out and we'd have 3 left over. So 6 plus negative 3 is 3. But we don't want to model that. We want to model 6 minus negative 3. We know that when we subtract a negative, our value goes up. And we want to model that with these chips. So instead of just adding negatives, I'm going to keep the value of our starting point at 6 by adding some positives to go with it. Now I'm not going to put them too close, because if I put them too close, they zip together and we can never separate them. It's kind of like an atomic feature that's a little bizarre. But if I click that there, 1, 2, 3, okay, and I keep them kind of apart from each other, because if I put it too close, like, oh, darn, it disappeared. They got together, and now I can't like separate them. If I try to pull them apart, they don't pull apart. So I'm going to get rid of that. If I hit the erase button, I get rid of that. So I'm going to add one more subtraction chip back, one more black chip back. So now I haven't changed the value of my starting point. 6 over here, and I've added a couple zeros, right? Negative 1 and positive 1, that represents 0, that represents 0, and that represents 0. So let me add the text box. We want to model 6 minus, and I'm going to use my parentheses again, negative 3 equals. And then we're going to find out what that answer is. Okay, so Now, instead of putting these together, right, because we're going to assume that they're already together, that's 0, that's a value of 0. We're going to actually subtract these negatives. Let's use the eraser to do that. Bing, there goes one, bing, there goes another. We just subtracted -2, and oh, there's another one. We subtracted -3. We subtracted 3 negatives, which is the same thing as -3. So we just subtracted -3, and look what we have left over. Now we have 6, 7, 8, 9. So if we click back up here, we know that 6 minus -3 equals 9. So we can model addition and subtraction using chips, positive and negative, black and red chips, and on the digital chipboard. Thank you for watching.